So in this section 3.5 questions, we are going to look at derivatives of trig functions. So to start with, I have just given you all the derivatives of the 6 trigonometric functions. The derivative of sine x is cosine x. The derivative of cosine is negative sine. The derivative of tangent is secant squared x. Derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x tan x. And derivative of cosecant x is negative cosecant x cotangent x. And then this is a special limit. The limit as x approaches 0 of sine x over x is equal to 1. So the first question here asks you to use this special limit to evaluate this. So what we are going to do is we are going to rewrite this very quickly. So how are we going to rewrite this? We are going to rewrite this as limit as x approaches 0 sine 3x over 3x. So you want this argument following the sign divided by the same thing, then that limit is equal to 1, right? But we didn't have 3x in the denominator. We had x in the denominator. That means we have to take away that 3, correct? Because we just had x. So if we did that, so basically what we have done is, so let me rewrite it in a different way so you can see what has happened here. So what I am doing here is, this is my original problem. Now if I multiply and divide by 3, this can be rewritten like so. And this limit becomes 1 times 3. Therefore, the answer is 3. Okay. Now we're going to do the same thing in here. What we are going to do is we want 3x over sine 3x, okay? And then we want sine 7x over 7x. But remember, the 3x was not there, so I need to take it away. The 7x was not there either, so I need to take it away, okay? So that the original, so basically, if you reduce all of this, what will remain is only sine 7x over sine 3x, which was the original problem. So I multiply by 3x, but I divide by 3x so that they cancel away. I divide by 7x, but I multiply by 7x so that they cancel away. Now this limit is 1. This limit is also 1. And this reduces to 7/3. So the final answer here is 7/3. All right. So in the next problem, you are asked to find the derivative. And here you have a product of two things. So what do we have the product of? We have the product of this and this. So we have to use the product rule. So when you use the product rule, I keep the first term as is, multiply by the derivative of the second. The derivative of sine x is cosine x, plus I keep the second term as is, and I multiply it by the derivative of the first, which is 12x cubed. So here you have to be very careful when you write your answer. So this is 3x to the power of 4 cosine x plus 12x cubed sine x. Now the most commonly made mistake is to multiply this x and the 12x cubed. You cannot do that. This x is the argument of sine. This is separate. So do not try to combine them. Okay. So bring it forward as the coefficient so that you will avoid that confusion. Okay, here I'm going to use the quotient rule for the next problem. So y prime will be, I bring the denominator up, multiply it by the derivative of cosine, which is negative sine, minus, keep the numerator, multiply it by the derivative of the denominator, all over denominator the whole squared. Then here I'm going to distribute. So I have negative sine squared x minus sine x minus cosine squared x all over sine x plus 1 the whole squared. So now I'm going to do a little thing here where I'm going to, so what I'm going to do is, because of lack of space, I'll write here So I'm going to try to bring these two together like so, okay? So now when I do this, what happens is I can take the negative out of the whole thing. Then I have sine squared x plus cosine squared x plus sine x all over sine x plus 1 the whole squared. Now you have to know this identity. Sine squared x plus cosine squared x is always equal to 1. So which means that what I have here becomes negative of 1 plus sine x over sine x plus 1 the whole squared. Now sine x plus 1 and 1 plus sine x are one and the same, so I can reduce that, right? So this becomes 1. So my final answer will be negative 1 over sine x plus 1 or 1 plus sine x, however you want to write it. Okay, so that is your final answer. Okay, so in this problem, you're asked to find y equals cosine squared x, but we haven't done chain rule yet, so you have to use an identity, okay? What is the identity that I'm going to use here? The identity I'm going to use here is that cosine squared x can be rewritten as 1 plus cosine 2x over 2. So this is um, a double angle identity. So this is what I am going to use. So now this can be further split up like so, okay? Now I take the derivative of 1/2 is 0, then I take the derivative of, so this 1/2 coefficient comes out, the derivative of cosine 2x is negative sine 2x, okay, times 2. Okay, so which can be written as negative sine 2x as my final answer. Okay. Okay, so we can revisit this problem. I'm going to put a star next to it so that we can revisit this after section 3.7 where we have done the chain rule. All right, here I have products and sum and difference of products. So be careful here. This is a product here, right? So I apply the product rule. So I keep the first term as is and then take the derivative of the second plus keep the second term as is, take the derivative of the first. Now all of this is the derivative of the first term. Now the second term is this. So what is the derivative of that? So plus, okay, 2w negative sine w plus cosine w times 2. Then I have the third term here. So there is a giant negative sign in the front. So whenever you have a negative, please start a bracket or a parenthesis so that you don't make any mistakes. Well, there is no product here, so we are good. So I'm just going to anyway keep that. So this derivative is 2 cosine w. Now I'm going to take everything out of whatever and rewrite this as w squared cosine w plus 2w sine w minus 2w sine w plus 2 cosine w minus 2 cosine w. So let's see what gets cancelled away. This and this goes away, this and this goes away, and that leaves me with the final answer of y prime is w squared cosine w as the final answer. Okay, so here I have a product of three terms, okay? There is an x, there is a cosine x, there is a sine x. So now whenever you have a product of three things, right? So if you have an f of x times g of x times h of x, like there are three separate functions and you're taking its derivative, what you do is you take the derivative one at a time. So suppose say you're taking the derivative of the first one, then keep the second and the third as is, plus then keep the first and the third as is, okay? And finally, keep the first and the second as is and take the derivative of the third. Okay, so this is what you are going to do. And that's what I'm going to do now. So let's do that. So y prime will be, what am I going to do first? Take the derivative of x is 1, correct? So the next two will remain as is, okay? Plus, then I keep the x as is, take the derivative of cosine, that is negative sine, but keep the third as is. Then I keep the first and second as is and take the derivative of the third. Now I combine them all. I have cosine x sine x minus x sine squared x plus x cosine squared x as my answer. Okay. All right. Next problem, I'm going to use the quotient rule. So when I use the quotient rule, I bring the denominator up. I take the derivative of the numerator. So derivative of cosine is negative sine, but since there is another negative in the front, the negative times a negative makes it a positive. Minus, I keep the numerator and take the derivative of the denominator all over denominator the whole square. So then I distribute, I have sine x plus sine x cosine x plus sine x minus sine x cosine x all over 1 plus cosine x the whole square. Now let's see what gets cancelled away. This and this gets cancelled away, and that gives me the final answer as 2 sine x over 1 plus cosine x the whole squared. Okay. All right. The derivative of secant is secant x tan x. The derivative of cosecant is minus cosecant x cotangent x. And that's it. There's nothing more to be done here. So here the derivative of x is just 1 minus I have a product. So I apply the product rule. So keep the first term as is, take the derivative of the second term, plus keep the second term as is, take the derivative of the first term. So that is 1 minus cosine squared x minus sine squared x. So the answer is 1 minus cosine squared x plus sine squared x. Now, if you want, you can do this. Remember this identity. Sine squared x is 1 minus cosine squared x, right? You remember this identity. Therefore, I can replace this whole thing with sine squared x. If I do that, my final answer will be 2 sine squared x will be the final derivative. Okay. All right. Here you have to find the second order derivative. So I apply the product rule. X times cosine x plus sine x times 1, which can be written as x cosine x plus sine x. The second derivative will be x times negative sine x plus cosine x times 1 plus cosine x. And this can be written as negative x sine x plus 2 cosine x. And that's your second derivative. Okay, that's it.